Okay, so copy down that problem, and let's take a look at it. What? Yes. Okay, so the question is, how can you tell if it instantly whether or not it needs U substitution? And can anybody think of what a reason would be? How can you look at a problem and say, this one needs U substitution? If you need the chain rule in some way. Okay, if there's something inside of something else, that's most likely one that you're going to have here. Okay, so look at this one. So any suggestions for what U would be? Good, x cubed plus 8. So what we're going to do in this one is I'm going to demo that change in variables thing that we did yesterday. It was the last thing. We're going to change this from the x world to the U world. And then we're not going back. Okay. All right, so that would mean this is equal to the integral. I'm not going to put those on there right now. I'm going to handle this part first. This is U squared. So this squared is U squared as long as x cubed is equal to x cubed plus 8 is equal to U. Now what's left over here you see is an x squared times dx. So we have to somehow figure out how that's going to play a role. So you're going to always take the derivative of this other equation. So let's do that. That's here. I tend not to right now because I guess I could put this in here, but this would be like an asterisk. Because once we go to use, you have to figure out how it matches up. So I'll put that in there, but we're going to end up having to go here. All right, so the derivative of U with respect to x is 3x squared. And then we're trying to match an x squared dx in order to replace it. So we just do a little manipulating here. So I got du is equal to 3x squared dx. And then the final step here is to divide by 3. We've done enough of these now. You're starting to get really familiar with that? Okay. Now I have something I can replace. So I can write this as 1/3 upper U squared times 1/3 du. Okay. Now, that's that part. Now what I want to do is I want to do the conversion of these. You see, this is an x value. It's an x equals -2 and an x equals 4. So we just have to put them into the translator and figure out what the u values are. So translator is right here. So what? U of -2 and u of 4. So we just have to figure out what those answers are. This is -2 cubed plus 8. That's 0. This is 4 cubed plus 8. 72 is good. So and then I'm just going to clean this up just by bringing the 1/3 out so you see the connection here. Integral from 0 to 72 of u squared du. This thing right here is the same exact thing as this. Okay, but we haven't gotten our answer yet. On the AP exam, I told you, you're going to have to do a multiple choice. I just know you are. They're going to give you this, and then they're going to say, choose from the following that best represents it, and you would pick this one. Okay, that's a really common question. All right, well, that's a really easy integral. It's just u squared. So we've got 1/3 times u to the 3, and that's 1/3 evaluated from 0 to 72. Well, that's a big number. Okay. I didn't see that one coming. Okay, and you know what? Since that's 1/3 and 1/3, I'm going to take that as 1/9. And this is going to be 72 to the 3rd minus 0 to the 3rd. (72 to the 3rd times 1/9). Well, you'd never be given one that's this mathematical on the multiple choice. 8 times 9, 8 times 9, 8 times 9, divided by 9. That still doesn't help very much. 72 times 72 times 8. All right, what is it? I give up. Okay, now I don't feel so bad. 41,000 what? 472? Yeah. It's right on the tip of my tongue.
So will this method always work?
Yes.
Okay.
This method will.
Steps for it? Because I feel like I'm going to forget this. Like, I always forget to take, like, the antiderivative.
I mess up the order because I'm like, oh, wait, the antiderivative up there.
Okay, let's try to write the steps. What would step 1 be? Yeah, so choose u. Step 2. Put u into the integral. So I would rewrite integral with u. That's what I did right here. That's the orange thing here. So I'll put a little 2 here. This was step 2. Then what do we do next? Find the derivative of u. Find du dx. Yeah. Yes. Do all the u's at once. I don't know what that means.
Like,
Do all.
sorry, like you find the derivative of u, then you solve for u, and then you solve.
Yeah. Yeah. See, this step 2 and step 3 could be interchanged. That order doesn't matter. Because ultimately, what are you doing? You want to write it like this. So finding du, and then I would say, in addition to this, manipulate to, shoot, it's not really find dx, but it's finding, yeah, to find the substitute. Because this one, it's not just solving for dx, it was finding x squared dx. That was just for this specific one. So then I'd probably say rewrite entire integral with all u's. That's where we wrote that. And then I'd probably say the last step is to handle the limits. Okay, those are called the limits, up the lower limit and the upper limit. And I'd say, How do you want to say that?
Find your U.
Plug in U limits? Or find U limits?
Yeah.
Okay. Find U limits using U equation. Because that's we're going to always use the translator here. That gets us there. And then I think we're ready to finish it off. So integrate with respect to U. Think that's okay? And the trick on this is that they're general steps because every problem can be a little bit different. Okay, let's do another one. Let's do, I got a good one here. Okay, you try this one. Okay, try to get the answer to this one. This is the integral from 0 to 2 of x over the square root of 1 plus 2x squared dx. Okay, go for it. And you can work with a partner if you want to on this. This is a 0 down here. I put the first hint up there. Remind me, I was never good with numbers. You get an answer of 1?
Yes, but I don't really know how to do it.
Yes.
This homework assignment is
Here. So, do you see that? Okay. And I identified that u is equal to, so all I said was substitute. So this is the same as u. So I wrote it as 1 over the square root of u. Okay. Yeah, that's a great question. This right here, let's stop and think about what fractions, generic fraction, 2 over 3 is really 1/3 times 2. So x over the square root of this is the same as 1 over the square root of this times x. So it's rewriting it into that form. Okay, any other part that you don't get? Yes?
How come you didn't like convert it like what I did? I brought denominator up with the negative 1/2 right away.
You did that like over here or here?
Yeah, like I rewrote the equation for it.
Doesn't matter. I wanted to make sure that everybody saw that it becomes, that this is equivalent. We did that substitution, and then I rewrote it. But as long as you're doing it correctly, you can rewrite it as soon as you want to. It's not like these are the exact steps. These are the steps to get there. Okay? Now, just stop and think. If we were to do it the way that we did not do change in variables, what would happen is we would have never done the 1 and the 9. Okay? If let's pretend we never learned change in variables, the u thing. You would never gone from 1 to 9. You would have still kept it as 0 to 2 up to here. But then at this moment, you would have taken the u and you would have put it back into the 1 plus 2x squared. And then you would have gone from 0 to 2, and this whole thing would have been using the 1 plus 2x squared to the 1/2. You still would have gotten the same answer.
So is there any way that's better when you're doing those?
I think this ends up being simpler because look at you don't have to do like a double plug-in. Okay, I think you've got enough tools to be able to do the problems, so homework is due tomorrow, and that would be that.